Let's learn about a way of various expressions using variables in this chapter. We will go through a fun process to make an example applying math-related concepts that we learned previously. First, we will take a look at the completed example and figure out what we are going to make. Like the one that we created from the first chapter, there is a circle, two lines of radius size in the circle, and an arc which is the circumference of connecting the two lines and the angle. As you might guess, it is an example to find the size of the arc and the radian value when the angle between the two lines and size of the radius inside are changed. Shall we review the radian, radius, and arc that we learned as we were studying about the trigonometric functions briefly? A circle is made of 360 degrees from the concept of an angle that we commonly use. A unit, radian, which means a ratio of arc's length s and radius's length r, is used at circular method. When the length of the radius and the arc length are equal, the radian value becomes 1. When the length of the arc is twice longer than the length of the radius, the radian becomes 2. It can be expressed in a general formula as radian equals s divided by r. The formula to find the circumference of a circle is 2 pi r. When the general angle is 360 degrees, the length of an arc is 2 pi r. The radian is 2 pi r divided by r and simply 2 pi. When the general angle is alpha degree, the value of radian is 2 pi multiply alpha divided by 360. The general formula to find the value of radian is summed up as radian equals pi divided by 180, multiply alpha. Since we know the value of radian, how should we find the length of arc s? Since the formula to find the radian is radian equals s divided by r, the formula to find the length of the arc can be summed up as s equals radian multiply r. Let's go back to the example and create the circle step by step. First, let's declare that the pi value as a constant, in the name of p. Once the pi value, 3.14, is entered in the input bar as shown below, it is declared as a constant without showing on the screen to use in a calculation later. Now, let's declare a variable named angle val which can change an angle freely. The typical method to use the features of variables at GeoGebra is using the slider. Create the slider that is familiar to us and use the changed values that are adjusted. We will select the slider icon from the toolbar as shown in the figure. Once you click the graphic view screen, a window to create slider pops up. Set the name, angle val, and change the type to angle. Then, the minimum and maximum values and the changed unit will be set automatically as shown in the figure. If necessary, the values can be changed. Since the maximum value of circle's angle is 360 degrees, we will use it as is. The variable name, radius val, which means the size of the radius, can be created in the same way, but the important thing to note is that the property must be set as number. Now, the calculated radian value will be entered in the variable named radian val. Since we studied about the formula to find radians previously, we will enter the formula as is. Enter radian val equals p/180 asterisk angle val in the input bar as shown in the figure. Notice that the angle symbol, O, is added to the result value of radian val. Since it is calculated with a variable angle val which has an angle property, the result value comes out as an angle. To fix this, /O must be added at the end of the calculation formula as shown in the figure. Once alpha button at the end of input bar is clicked and the degree symbol is selected, the angle symbol, O, will be entered. The variable arc val, which means the length of the arc, can be created a little easier. Enter arc val equals radius val asterisk radian val according to the formula to find the length of the arc previously. Now, let's create the points. Let's make a center point with coordinates 0, 0, which is named as A. And create a point that is on axis as B, and coordinates are the length of the radius. Enter B equals radius val 0 in the input bar. We will position the third point C to a place that is rotated by angle val from the point A based on the point B. The GeoGebra command to create the point C is summarized as C equals rotate B, angle val, A. Once the 3 points are completed, with the point A as the center, draw a circle with a radius of radius val, according to the circle drawing method that we learned from the previous chapter. Create the lines between the point A and B and the point A and C according to the method that we learned previously. At this time, we will draw an arc that connects the point B and C. Select circle arc with center between 2 points within the menu that draws a circle as shown in the figure and the points A, B, and C respectively. Then, the desired arc will be completed. Let's create texts to show a title, the radian, and the length of the arc. The text can be created by using insert text icon as shown in the figure. Once texts are created, enter a proper name and contents to be displayed. When you want to show the variables such as the radian and the length of the arc, select the applicable variable object in the properties as shown in the figure. The one last process is showing or not showing the text by using the checkbox. When checkbox to show /hide objects is selected and the screen is clicked, the checkbox will be generated as shown in the figure. When the checkbox is generated, select the objects that would be adjusted and place it in the proper position to complete as shown in the figure.